Question 9 starts with two parametric equations, x in terms of t and y in terms of t, and we're asked to prove that the Cartesian equation is in the form y equals a ln x plus b. Here are our two equations. I've labelled this equation 1 and this equation 2. Let's just muck them both around and see, because I've got to get t on its own somehow. This is quite a hard version of this question because it is not obvious how to get t on its own. So what I suggest to do to start with is just muck them around slightly and see what ideas you can come up with. This one, certainly by the log law, I can put the 6 as a power on the t plus 3 bracket. So this is equal to ln t plus 3 to the power 6. Now, we could factorize this, but that will give us two expressions for t, which would be a nuisance to try to substitute that back into equation 2. The trick here is to realize that we've got to complete the square. In completing the square, we will halve this coefficient of 6 to 3, and that becomes the bracket that we square. So if we complete the square, x is equal to t plus 3 squared. Now that will give us the t squared and the 6t, but it will also give us a positive 9 that we won't want. So I want to take that away immediately and then just copy and paste the negative 16 on here. So I get x is equal to t plus 3 minus 25. T plus 3 appears in our log equation. So if I make this the subject, I'll be able to substitute this into the expression for y, and that should give us the Cartesian equation. This is how it does. So I get t plus 3 squared is equal to x plus 25. But we want t plus 3 raised to the power 6. So if I raise this to the power 6, I have to raise this to the power 3. So I get t plus 3, now raised to the power 6, is equal to x plus 25 raised to the power 3. Now we can substitute straight into equation 2 and get an answer. So therefore I can say that y is equal to ln x plus 25 raised to the power 3, which is equal to 3 ln x plus 25, which is what they wanted. So therefore a is equal to 3 and b is equal to 25. And that's the answer. So in part B, we've been asked to find the tangent to the curve at the point that it crosses the y-axis. So this is the point where x is equal to 0. And to get to the equation of that tangent, we have to go via the gradient of our curve. So having got the Cartesian equation, we can differentiate, find the gradient, and then form an equation of this straight line. So dy dx, the differential of this log function will be 1 over x plus 25. So this is equal to 3 over x plus 25. Now, because we're at x equals 0, we can sub x equals 0, and we get that the gradient at p is equal to 3 over 25. Now we can use the rise-run expression for the gradient to work out the equation of the line. So I can say that y minus the y-coordinate where x is equal to 0, which is 3 ln 25, divided by x minus the x-coordinate, which is 0, is equal to 3 over 25. Cross-multiplying, I get 25y minus 75 ln 25 is equal to 3x. Let's see what form they want it in. They want ln 5, not ln 25. Well, happily 25 is 5 squared. So if you imagine the 5 squared there, by one of the log laws, this turns into 150 ln 5. So we get 25y minus 150 ln 5 is equal to 3x. They want the ln 5 over on the right-hand side and the y and the x on the left-hand side. So therefore, 25y minus 3x is equal to 150 ln 5. And that should be your answer.